This presentation is an assessment of compensatory mitigation policies used to restore wetland habitat in California through a spatial analysis of the change in NDVI over time. This project is brought to you by Kathleen Kashiri of the Geospatial Analysis Lab at the University of San Francisco. This project specifically investigated wetland mitigation projects in Southern California permitted by the Los Angeles Division of the Army Corps of Engineers through the Clean Water Act. California wetlands are one of the most productive ecosystems on Earth and provide significant habitat for a variety of migratory birds and aquatic organisms. They improve water quality by filtering pollutants and recharging ground aquifers. Additionally, they capture and store significant amounts of carbon dioxide, which is a potent greenhouse gas. Section 404 of the Clean Water Act protects these ecologically significant California habitats through environmental mitigation regulations. If a permittee is granted a 404 permit to discharge dredged or filled materials into wetlands, they must offset those environmental harms through compensatory mitigation practices. There is growing concern regarding the effectiveness of the Clean Water Act in protecting natural wetland habitats. Studies have shown that the enforcement of mitigation policy does not always ensure a no net loss to wetlands, and in many cases the acreage of viable wetlands has decreased over the years. The goal of this project is to understand if mitigation has been successful in preserving wetland habitat in Southern California. The Normalized Difference Vegetation Index, or NDVI, was chosen to represent ecosystem function of wetland habitats because it is a measure of the density of green or healthy vegetation. Values range from -1 to +1, with lower values representing less healthy vegetation and higher values representing healthier vegetation. The specific research questions of this project are the following. 1. Does the NDVI increase over time with mitigation efforts? And 2. Is there a correlation between the length of a mitigation project and the overall success of that project? To begin the analysis, data was located from several sources, including the Landsat 5 and 8 NDVI image composite dataset sourced from the Google Earth Engine and the U.S. Army Corps of Engineers Compensatory Mitigation Sites dataset. The first geoprocessing step was to edit and process the mitigation sites dataset to match the scope of the project. Some of the mitigation project areas were split up into multiple attributes, so the merge geoprocessing tool was used to merge each project into one specific attribute. The restoration duration analysis was done by subtracting the start date from the end date of each mitigation project to get the specific amount of days representing the restoration duration. The mitigation sites area dataset was then added to Google Earth Engine as shown here in red. The NDVI values were generated by merging the Landsat 5 and 8 datasets to get a span of NDVI values from 1995 to 2018. The subsequent NDVI map was then clipped to each mitigation project boundary. The average NDVI was recorded for each year from 1995 to 2018 for each wetland mitigation project. The results of the NDVI analysis found that on average, the NDVI increased 0.118 from 1995 to 2018 for the mitigation sites. The subsequent chart created in Google Earth Engine represents the average NDVI value from 1995 to 2018 for each of the 110 wetland mitigation projects. It was difficult to ascertain any patterns in the change in NDVI over time, so several charts were generated from the analysis to investigate the changes in NDVI on a project-specific basis. There were no significant patterns revealed in the data, and the average change of 0.118 in NDVI indicate that while there was a slight positive upward trend, mitigation efforts did not significantly affect NDVI. This data was then spatially represented to compare changes between different mitigation projects visually. Most projects had an increase in NDVI of 0.15, symbolized by the yellow circles, with several projects having larger increases in NDVI, symbolized by the larger dark green circles. The results from the restoration duration analysis found that the average mitigation project lasted for 220 days. This data was spatially displayed to compare the amount of time each restoration project lasted for. There were several projects near Santa Ana that lasted for a longer amount of time, as displayed by the dark green circles. Projects that lasted for short amounts of time were distributed throughout the study area and represented by the red circles. This data was then charted against the NDVI results, and the subsequent trend line illustrates that there is a small positive correlation between the amount of time taken to restore a habitat and the change in NDVI. The results from this analysis indicate that wetland mitigation efforts are only slightly increasing the NDVI of wetland habitats. This is troubling because for every mitigation site, there is a wetland habitat that is legally being destroyed for development. The lack of success of these mitigation projects could be contributing to the decrease of our California wetlands. Furthermore, the amount of time spent restoring a habitat has only a slight positive effect on the ecosystem function described through NDVI over time of that habitat. The accuracy of the results from this analysis can be improved by removing the effect of precipitation on the NDVI data. Precipitation has a significant impact on NDVI, therefore the NDVI results are highly skewed to the yearly precipitation amounts. Removing this precipitation bias from the data will hopefully reveal NDVI patterns related to mitigation efforts and improve the overall accuracy of this assessment. I want to acknowledge and thank all of the people who assisted with the development of this project, including researchers at the University of San Francisco, Dr. David Saw and Megan Danielson of the Geospatial Analysis Lab, as well as the agencies that provided the data for the use in this project, including Google Earth Engine, the United States Geological Survey, and the U.S. Army Corps of Engineers.